Hey guys, this is part 2 to graphing curves, curve sketching they call it. It's 4.6 in your book, and this is number 33. And I picked one of the more difficult functions, matter of fact the most difficult one I think in that group, so you could see one that was a little easier like number 18, and then one that was a little bit more difficult like number 33. So this one is a log function. And it says log base 4 of x minus x squared. That's our function. We want to know how this thing looks and how to graph it without using our graphing calculator. So we're going to do a couple of things. We're going to find the x-intercept first, which I color coded. X-intercept is pink. By setting this equal to 0 and solving, and what I do is I use my log property, which says 4 to the 0 equals x minus x squared. 4 to the 0 is 1, and then I subtracted it over to the other side to get this negative 1. When I then rewrote it like this, or so to speak, I brought everything over to the left side, I used the quadratic formula to try to find out what x was because this thing doesn't factor. And it turns out that under a radical we have a negative. When that happens, then there is no x-intercept. Likewise, when I put a 0 in for y and try to solve this, a 0 in for x to try to solve for the y-intercept, which is blue, what we're doing is using that log property again to say 4 to the y equals 0, because if I put a 0 in for the x's, I get a 0. And then this, 4 to what power is going to give us a 0? There isn't 4 to any power that could give us a 0. You could actually take the log of both sides and solve this. But the point is, you can't raise 4 to any power to make a 0. Therefore, there's no y-intercept either. So this graph either happens above the x-axis or below the x-axis, never touches the y-axis, and never touches the x-axis either. This seems to tell me there might be some asymptotes here that is making this thing hug this thing and never cross the two axes. The next thing we want to do is find critical points, which is green, and what we're going to do is take the first derivative of this function. Now to get the first derivative, you have to see page 177 for a logarithm derivative, which we didn't go over that much, but it's very easy formula to use. Pause the video, take a look at that, what the derivative of a log function is. And this is what it comes out to be. When I set it equal to 0, notice that I only set the numerator equal to 0 because I don't care what the denominator is. As long as it doesn't come out to be 0, I'll make it undefined. But if I set the numerator equal to 0, I'll find out what x is. It's real nice. It comes out to be 1/2. To get the point, and I didn't mention this in the other video, but to get the critical point, you take that x value and always plug it back into the original equation to find out what your y value is. To get your critical point, and the same thing with points of inflection, you take your x value that you just solved for and put it back. We always go back into the original one to get the y value. Now that I know my critical point is then 1/2 -1. This is the point in which the graph changes direction to either going up to going down or from going down and turning around and going back up. That's what the critical point gives us. This point's either a minimum or a maximum. Let's find out more about it by taking the second derivative. So if the first derivative is this, I just brought the constant out front, and don't forget that an ln is a constant. And now I have a quotient, and I use my quotient rule. The bottom times the derivative of the top minus the top times the derivative of the bottom. I simplified it, and I set it equal to 0. So I take the second derivative and set it equal to 0 to find out my points of inflection. When I set this equal to 0, some things canceled out and I got this. And again, I use my quadratic formula to find out that it's not a real number because I get a negative inside here, which tells me there's no points of inflection. So that means this thing doesn't change concavity either. when I look at my original function, I notice that if x were 1, now you can't take a logarithm of a negative number, because really what we'd be saying, 4 to what power, or let's say we can't take, this thing will never become a negative, so the only way it'll become a negative is if this is a 0. So think about this. If I put a 1 in here, and I get, let's do it on the other side, x minus x squared. If I put a 1 in here, 1 minus x squared, and I got log base 4, and I want to know what y is. So I have log base 4 of 0 equals y, and I'm going to go 4 to the y equals 0. Once again, I don't get anything. That means that at 1, this function is undefined, and when the x values make a function undefined, that's where we have vertical asymptotes, just like if you were to get a 0 in the denominator. So we got a 0 in the denominator, and so at 1, so we have an asymptote at 1. If we put a 0 in here, we would also get that. No other number, 2, wouldn't work. 2 minus 2 squared, that's 4. I'm getting a negative. 4 to something could give me a negative. It would just be a reciprocal. Think about this process. This gives me an asymptote at x equals 0 and x equals 1. That means our graph never touches. So I have a critical point, like we said before, at 1/2 negative 1. But the question is it a U-shape like this, or is it a downward U-shape like this? I have my suspicions that it's downward because we already said that there was no x-intercepts, and how could it be like that? But the other thing I could do in another situation is test on either side of the critical point. If I test it 1/4, say, into the first derivative, this would become a positive, which tells me the graph is going up. If I tested a 3/4 into the first derivative, this would be a negative and tells me that the graph is going down. So this is the graph I get. Take some time to digest these two before you start to do any homework. Really digest them, think your way through, watch this video over and over again, and then try 1 or 2 on your own that are some of the simpler ones. The process is you find the x-intercept, then you find the y-intercept. Find the first derivative, which gets you your critical points, by setting the first derivative equals 0. Find the second derivative, which gives you your points of inflection when you set the second derivative equals 0. Now you have all the points where the graph crosses. Now you just got to find out whether it's going up or down. And you're testing on either side of the critical points, either side and in between, to find out if I test those numbers that are in between the critical points in the first derivative. And if I get a positive, that means that graph is going up. If I get a negative, it means the graph is going down. And you can test points on either side of the points of inflection too. If you get a positive on one side of a point of inflection, that means you're concave up. If you got a negative, it would mean concave down. Really take some time to digest these fully before you go on to any other ones. And on Wednesday, I'll answer any questions that you have. Good luck. Bye-bye.